Hi, welcome to the Olympiad geometry. Let's continue our study of Stewart's theorem. Prove that there is one and only one triangle whose side lengths are consecutive integers, and one of whose angle is twice as large as another. This is an IMO-10 problem. It's the first problem of 1968 IMO. So we just draw the figure first. We can set angle B equals to twice of angle A, right? And we know that all the side lengths are integers, consecutive integers. So there are two cases. The first case is that angle B is the largest angle. And the second case is that angle C is the largest angle. And from the set of the problem, we already know that we want to prove only one triangle satisfies these conditions, which means only one of these two assumptions is valid. Let's check the first one. If angle B is the largest angle, means that AC is the longest length, has the longest length. So that means if we set the middle length of the three sides to be x, AC is the largest one. So AC equals to x plus 1. And BC is the shortest one. So BC equals to x minus 1. And AB equals to x. That's for the first case. Okay, case A. And because angle B is twice of angle A, so we can do an angle bisector on the angle B. And this angle bisector intersects AC on point D. So we know that angle ABD equals to angle A equals to angle DAC. Based on this, we can have our first equation. Let's set the length of the BD equals to y. So we can have our first equation that AB divided by AD equals to BC divided by DC. Right, because this angle equals to this angle. And also because angle ABD equals to angle A, so the length of AD equals to y. The length of DC equals to x plus 1 minus y. So we can replace AB, AD, BC, DC into these xy. That means AB is x divided by AD, which is y, equals to BC, x minus 1 divided by DC, x plus 1 minus y. This is the first equation, and we can get the second equation by Stewart's theorem, that BD squared equals to, the long equation from AB, BC. Let's review that theory. The Stewart theorem is saying that in a triangle ABC, we have AP here. Then we know the AP squared equals to AB squared times PC divided by BC plus AC squared times BP divided by BC minus BP times PC. And we know that we already derived this special case, but let's do it again. If AP is the angle bisector of angle BAC, right? Then we know that BP divided by PC equals to AB divided by AC, which means BP to BC equals to AB to AB plus AC, and PC to BC equals to AC to AB plus AC. Right? That means we can have AP squared equals to AB squared times AC to AB plus AC squared times AB to AB plus AC minus BP times PC. This equals to, because we have AB squared times AC squared times AB, so we can extract AB AC out, and here we left AB divided by AB plus AC, here we left AC divided by AB plus AC, and AB divided by AB plus AC divided by AB plus AC, that's 1. So we have AB times AC left, minus BP times PC, which means when AP is an angle bisector of angle BAC, the length of AP square equals to AB times AC minus BP times PC. So for here, we got BD square equals to AB times BC minus AD times DC, which means we have BD square, that's Y square, equals to AB x times BC, that's x minus 1, minus AD is Y. The length of DC is x plus 1 minus Y. This is first equation, this is second equation. So from the second equation, we got y squared equals 2 x minus 1 minus y times x plus 1 plus y squared, right? That means this cancel each other, so we can transfer the y times x plus 1 term on the left side of the equation, and then we can divide it by x plus 1, so we got y equals 2 x times x minus 1 divided by x plus 1. We can replace y in this equation, so we got x, let's write another form, x times x plus 1 minus y, y is x minus 1 divided by x plus 1 equals 2 x minus 1 divided by x plus 1, that's y times x minus 1. We can multiply x plus 1 on both sides of the equation. So for the first equation, we got x. For the left side, we got x times x plus 1 squared minus, that's x squared, times x minus 1 equals 2 x times x minus 1 squared. So this plus 1 squared minus 1 squared, and we notice that we have x in all three terms, and we know that x is not 0, which means x plus 1 squared minus x minus 1 squared equals 2 x times x minus 1. This one, we got 4x, right? For here equals 2 x squared minus x. So we have x squared minus 5x equals to 0. Because x is not 0, so x equals to 5. And then we know that x minus 1 equals to 4, and x plus 1 equals to 6, right? So that's our first triangle. And we need to prove this triangle is not exist. So I'll just write it on this part. The second case is that we're assuming angle C is the largest one, which means we have B here, A here, the same methodology, but because angle C is the largest one, so AB equals to x plus 1. Because angle A is the smallest one still, so BC equals to x minus 1. It doesn't change here, right? And AC equals to x. So let's set this as y, which means AD equals to y. And DC equals to, because this is still the angle bisector, this angle equals to this angle, and equals to angle A. That's why here is y and AD is y. So DC is x minus y. Then we got two equations here, which is x plus 1 divided by y equals 2, x minus 1 divided by x minus y. Right, and the second equation, y squared equals 2, x plus 1 times x minus 1 minus y times x minus y. So from the second equation, this is first one, this is second one. From the second equation, we got y squared equals 2, x plus 1, x minus 1 minus yx plus y squared, which means y equals 2, x plus 1 times x minus 1 divided by x. Right, we replace y in the first equation by using this term, so we got x plus 1 times x minus y, which is x plus 1 x minus 1 divided by x equals 2, x minus 1 times x plus 1 x minus 1. Right, so we can multiply x on the both sides of the equation, so we got x squared x plus 1 minus x plus 1 squared x minus 1 equals 2, x minus 1 times x plus 1, x minus 1 squared actually. So we have x plus 1 on all terms, and we know that x is not -1, so we can simplify this equation to be, I'll just write it here, x squared minus x plus 1 x minus 1 equals 2, x minus 1 squared. Right, so we extend this one, x squared minus this one is x squared plus 1 equals 2. Here we got x squared minus 2x plus 1, which means x equals to 2. And we know because x equals to 2, so x plus 1 equals to 3, x minus 1 equals to 1. Here is a problem. 1 plus 2 equals to 3, which means this is not the length of the triangle, which means that we only have one valid solution, that x equals to 5, x minus 1 equals to 4, x plus 1 equals to 6. That's the only triangle satisfy all the conditions. Okay, so this is the IMO-10 problem, and here we got one equation. Basically, we got one equation from the angle bisector theorem, and we got another equation from the Stewart theorem. I hope you like this video. We will talk about more about the Stewart theorem in following videos. Thank you. See you next one.